Hey folks, so we should have just finished reading in some data. First of all, I'd like to say something I forgot to mention in the previous video, which is you should save this file. So click save, and we'll save it in the same folder, and we'll just write it, I don't know, say reading data. Or actually, maybe I'll just call it analysis.r. So now it's saved. So if we go back to our folder, you can see that we have that analysis.r file there. It's essentially just a text file, but it's just useful to save that just so that we have it for later. In case we leave, come back, we still have our code written there, so we don't have to write it again. One thing you might notice is I've also generated another file here in between videos called random data. I'm just going to use that instead of the actual memory game data so that, there's something for you to do. So you don't just have to copy all the code I have. You have to change something at least, So, cool. If we go back to here, we can adjust that here. So I'm going to copy that, and I'm going to comment that out. So what this does is the hash essentially tells R that this line of code is just a comment. It's just text, like I would write here, reading in data, just to let me know that that's what this code does. So this line of code won't actually be run now. This one will though. So I'm going to do this one. I'm going to change this to random data. Now if I run that, and we'll take a look at the head of it, down here we can see teachers Mr. A, time, blah, blah, blah. And if we take away the head, it'll actually print out the whole thing. You can see there's a whole bunch of it. It goes down Mr. C, there's a Mrs. B there as well. Miss B. Cool. Okay. Now, what can we do with this? Well, usually the first thing we want to do is make a plot of something. But first we want to just select which data we want to make that plot with. So we could, for example, select Mr. C's class from here. And the way we do that is using the function subset. So I'm going to create a new variable. So I'll give it a name. I'll call it mem.c. And for Mr. C, and I'll assign to that using the equals symbol the subset of mem.data, which is all of our data, the data we just read in from the CSV file, where the teacher is equal to Mr. C. Now, you need two equal signs here because what this means is logical equals. So the variable, the column that's headed with teacher, so you can see at the very top of this, if I do this, you can see the column whose title is teacher has a value that is equal to Mr. C. That's what this means. So if I type this in here, then this just has, oops, typo, just has the Mr. C's classes data. Now we can do things with that. Like, for example, we could make a box plot. Let me just move my face so you can see. Ooh. Now that's not actually done exactly what we want because I forgot to tell it what I want a box plot of. I actually want to make a box plot of time. There it is. Cool. And traditionally box plots are horizontal, so I can say horizontal equals true, and it'll make the box plot horizontal. Perfect. I could even compare two classes. So, for example, if I go AC subset mdata where the teacher is equal to Mr. A, or, that's what this line means, it means or, logical or. So either the teacher is Mr. A or the teacher is Mr. C. That'll give me the data from both of those classes, but excluding Miss C's class. Then I could come here and I could do AC. Well, actually, what I would want to do is say that the data is equal to mem.ac. And here what I would do is put what's called a formula. So teacher versus time. This is a tilde symbol. It means we want to plot one thing against the other. So what that's going to do is produce parallel box plots. If I wrote it correctly, I think I got these the wrong way around. My bad. So if you just do it the other way around, there you go. Nice, and it's got Mrs. B there as well because because it's a factor. I can fix that actually. So if we go back up here, I'm actually just going to add strings as factors equals false. What that means is when it reads in the teacher column, it will read them as literal strings, as characters, values, rather than as factors, and then that'll fix this problem. So if we take this subset again and make this box plot, there we go. We have Mr. A's class and Mr. C's class, box plots, parallel, perfect. We can easily compare. We can also calculate 5-number summaries. So for example, we could do summary of mem C. So that's this one. And this generates, again, I forgot to tell it what I want a summary of. So I want a summary of time. Notice the dollar symbol. The dollar symbol means selecting the column time. So this essentially takes a column in a data frame. Lots of extra information here that you don't need. All you really need to know is that if you type this, you get your summary here. So it gives us the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. So this is essentially the 5-number summary plus the mean as well for free. If we want other things like standard deviations and so on, we can go standard deviation, SD, mem.c, time, and that's the standard deviation for Mr. C's class. You can correlate these with the box plot as well. So you can see the minimum value is 40, right? First quartile is at 46, so that's where this line would be for Mr. C's class. The median is at 51, right here, right after 50. The third quartile is 57, right here. And the maximum is 71, right here. So yeah, that's box plots and summary statistics. You can also calculate medians and means, just like standard deviations, but you can also get them out of the summary, just like that. You can get the mode as well. Mode, mem.c. Never mind. Actually, you'll be able to get the mode from the cumulative frequency table that we'll do in just a minute.